Hi, this is Miguel Valenzuela, and today we're going to be demonstrating a little bit of how Inventor works. First of all, we're going to be creating a pipe with some flanges here. The flanges come from what's called an I-part that has been created that is primarily a database of dimensions that allow you to modify the part on the fly and import it. Here's the vault right here. It's already been created. We're going to resize it so you can see how when you resize it, it automatically updates the whole vault itself. Now we're going to go ahead and insert these pipe sticks that we just created. We are setting them off to a specific distance from the wall with a mate parameter. And this is like building with Legos. You're inserting the parts. Here we are creating the views on the drawing that are automatically created with a cross section there. Then we're going to take some dimensions from the center line of the pipe. These dimensions are not forced dimensions, they are automatic, and they update dynamically based on the model itself. Now we're going to demonstrate what happens when we modify the actual width of it. Notice we've shrunk the width down and the model has updated in the drawing. We'll go ahead and change that back. We're going to modify the height of it, and the height of the drawing has also changed too. So you can see how changes can be made really easily with this with Inventor. Now the next thing we're going to do is we're going to create a segmented elbow using AWWA standards. What we'll do is we'll create construction lines first. These construction lines will allow you to use these as guides when creating the elbow. So first we create the amount of segments that we're going to use, transfer them into construction lines, apply parameters to them with the appropriate angles, then do some more construction lines. And give it some dimensions for the center line of the pipeline. Now you can either enter these manually yourself and adjust the angles, or you can use a radius based on a circle that's also a construction line. Once that's created, we go ahead and put some more parameters to the lines to make sure that the dimensions have been finalized and all the constraints or the drawings fully constrained. Now what we're going to do is apply the cross section to the pipeline, or to the elbow, which in this case is a 24-inch pipe, 3/8 inch diameter thickness. Now we saved that. We're going to go ahead and extrude some of the ends of it. Again, these are based on AWWA standards, just coming off of the actual standards, the measurements. Now this is typically for welded steel pipe, and we're going to add some flanges onto the end of these pipes here. Again, the flanges come from the I-part and are selected from a table that's already been created that allows you to only create one part and dynamically create multiple parts based on the need. We add these parts and then we add constraints to it to make it flush with the edges of the parts. Now we're going to go ahead and make a T. The T again is from AWWA standards. We create this by creating a sketch and then extruding that sketch across the required planes. Once the parts have been extruded, you'll notice that there's some conflicting parts in there, so we need to go in there and remove them. We'll do that by extruding and subtracting, or using what's called Boolean subtraction. And now we're going to go ahead and add these parts to the model, or to the assembly of the structure. We're going to add the T in mid-air because we do not have the valves yet to add to the structure. Once the T is added, we need to orient it. There's several ways to orient it. You can match different planes. You can match to the wall or offset it from the floor, or offset the angle from the wall. You can also rotate it manually. Of course, rotating it manually doesn't give you the precision that you want. Okay, so we're going to rotate it 180 degrees from the offset there, or 270 degrees. Now we're going to add flanges to the T. And then once we add those flanges, we'll add constraints to those, so that way they match up and are flush with the ends. Now this is about 600% sped up, so this whole, the amount of work that we're doing here is about an hour's worth of work to the end of the video. And as we're doing this, we're noticing that the drawing is being updated automatically. Again, this is just like building with Legos. You're taking the components that are made in advance from the library that you created. And here's a standard, this is a Venturi meter that was actually provided by the manufacturer. Now we've added a BOM, or a bill of materials list, that is automatically updated based on the items in the 3D model. So every item that's added to it can be located in the bill of materials, so we can do takeoffs from it. The original drawing calls for the valve to be right next to the Venturi meter. We're just adding an extra piece of pipe here, and we're going to add the Venturi meter, or the valve, to the flange off that pipe. Now we're building it piece by piece. You can build the pipes with the flanges and then add them in later. The pipe is actually an I-part 2, has already different sizes that are predetermined based on the table. Then we'll go ahead and add our fancy elbow that we created. Then add constraints to it. You'll notice that the hole does not match where we originally placed it. So in order to match that, there's a couple of ways to do it. The hole is entered in there manually, so there's no relation between the hole and the pipe. That can be created at a later time. Or we can just do a measurement from the side of the wall. And we'll take a measurement from the side of the pipe to the side of the wall there, and we're changing that measurement to match up that hole. Still not matching up. Change the measurement. There we go. Okay, so now we have our drawing. Most of our structures, it's about, let's say about 50% there. We don't have a lot of the appurtenances and other supports on there that are needed. But for the most part, the majority of the larger part of the work has been done. So that way if any more changes need to be done, they can be done at this level before going into the details. Thank you.